Hi, I am Lauren Vieira, and I'm here to tell you about hydrophilic and hydrophobic solutions or substances. So we'll start with hydrophilic, which is a water-loving substance. A hydrophilic substance will have polar molecules in it, just like the water does. So when you have two substances that both have the polar molecules, they're able to kind of be more cohesive and be able to interact with each other. And when you take a polar molecule substance like sugar and put it into water, it will dissolve into the water because the molecules are able to connect with the water molecules. Hydrophilic substances dissolve in water. So like I said, water with sugar, anything like that, where they combined and make one new substance. Hydrophobic solutions or substances. So hydrophobic is the opposite, which means that it isn't water fearing or does not dissolve in water. The hydrophobic substance is basically anything along the lines of like lipids. So what we just learned about, fats, oil, wax, anything where it can kind of create, in a lipid is able to create almost like a shield, so that water can't penetrate it and it can keep its shape, whatever that shape may be. And it's nonpolar. So when you have a lipid or a nonpolar substance that's trying to bond with a polar molecule, they just don't. They don't like each other, they separate, they stay separate, and they don't mix. They don't dissolve. Instead, they would just kind of sit around each other. The best and easiest way to describe this is if you had a glass of water and just decided to pour some olive oil in it for whatever reason, you would notice that the oil would just sit on top of the water or maybe form little bubbles. My dog is done with me explaining this, but so they're not gonna combine together at all. They're gonna stay separate, and you're gonna see the differences between the two, which actually I will show you in just a moment. Right, so example of a hydrophobic solution. So water, very clean brittle water, into this only clear cup that I own. I own no other clear cups. Right? We're gonna waste a good amount of water there, I guess. Alright, this is olive oil. Trust me, it's olive oil, I promise. Nothing else goes in there. And when I drop it in, let's see if we can get, a not crazy reflection. Nope, that's worse. Okay, I think we'll be able to do it. Alright, you see it kind of drop and make bubbles, and it does not settle and dissolve into the water. Instead, it just forms this little cloud of bubble oil on top of the water. So the oil is a nonpolar substance and the water is a polar substance, and they're not going to make a hydrogen bond and love each other. Instead, they're going to hate each other, and that's what happens. They just stay away from each other. They don't dissolve. Alright, we cleaned the cup. We are now pouring the polar moleculed water into the glass. It's going to be so much fun. I feel like you know what happens next, but we're making it fun. It's science. Okay, we got to put it down. I feel like I'm on my own YouTube video. Is this TikTok? Is this how it works? This is my sugar. If you believe me, I don't know, but I promise it's sugar. I take a nice big tablespoon of sugar and hope my dog doesn't eat it all. And toss it right into the water and give it a nice mix. You can easily tell the difference. So right away, you don't have the two different solutions. I put way too much in for this, but that's okay. I'm still mixing it. I'm just keeping it away from the doggo. Do not hate each other. They both have polar bonds and are just going to dissolve into each other. Oh, I wish I didn't have the glare, but you can tell a lot easier than that last one I did. So this cup of water is clear, whereas the other one had the oil sitting on top. That still doesn't help. There it is. Clear water. It was great talking to you guys. I hope you have a great night, and good luck in class. We're gonna kill it.